In this lecture, we'll introduce you to the idea of a conceptual architecture. If you're a hobbyist, then you may not need a formal architecture. However, it's always good to sketch out how your system will work together, no matter how simple the system. Also, an architecture can show you where you can replace components or capabilities. For example, we refer to our data provider in this course, but you can replace that with your own data provider and show this in your architecture.
A conceptual architecture is a high-level abstraction of a system that defines the main components, their relationships, and how they work together to achieve a set of goals. It's a blueprint that helps stakeholders understand the system's overall design and behavior, without getting into the technical details of the implementation. A conceptual architecture is often represented through diagrams, such as flowcharts, block diagrams, or data flow diagrams, which show the components of the system and how they interact with each other. These diagrams provide a visual representation of the system's structure and behavior, making it easier to understand and communicate. Our conceptual architecture comprises three main tiers: data ingestion, data storage, and data analytics. The three-tiered architecture we're implementing in our scenario is a common design pattern used in data-driven applications, though we're implementing it in a simple way. The first tier, data ingestion, is responsible for collecting and processing data from external sources. In this architecture, a Python-based application is used to leverage the mysportsfeeds.com APIs to retrieve data and transform it into a format that can be used by the other tiers. The transformed data is then written into CSV files for storage and analysis. The second tier, data storage, is where the CSV files produced by the data ingestion tier are stored and manipulated. In this case, Excel-based CSV files are used to store and transform data. In real-world use cases, this tier may also include additional data storage solutions, such as databases or data warehouses, depending on the size and complexity of the data being processed. The final tier, data analytics, is responsible for presenting the data to end users in a meaningful way. In this conceptual architecture, a Power BI-based dashboard is used to surface data from the CSV files stored in the data storage tier. The dashboard provides different reports and visualizations that allow users to analyze and understand the data. You're already familiar with Power BI from our last lecture. The three-tiered architecture has several advantages, including scalability, modularity, and flexibility. In this slide, you can see the conceptual architecture gets a bit more real. The data ingestion tier includes mysportsfeeds.com endpoints to access the data and Python to request and normalize the data. The data storage tier is the CSV files, of which there are two in this project, one for team stats and the other for player stats. Daily refreshes of the Python script update these CSV files, such that the third tier, the data analytics tier, is always using the latest data from mysportsfeeds.com. As you work more with Python and other sports feeds, you'll see ways to extend on this conceptual architecture. For example, you may use other data sources and integrate them to be able to do your own feature engineering for custom data. For machine learning, you can extend the data storage layer to relational databases or cloud storage systems. And you can cross-leverage the data storage layer for other data consumers beyond Microsoft Power BI, such as Tableau or websites. The architecture is designed as modular to provide flexibility and scalability. This means that the system is broken down into smaller, independent components or modules, which can be developed and maintained separately. This approach enables easier integration of new features or updates, reduces the impact of changes on the system, and makes it easier to scale the system as needed. Another advantage of a modular architecture is the ability to rewrite the system to point to a different data source or set of APIs. For example, if the current data source becomes obsolete or unavailable, the system can be quickly adapted to work with a new data source or set of APIs without having to rewrite the entire application. Currently, the system is using CSV files to store data. However, these could be replaced with the persistent right to a managed data store, such as a database or data warehouse. This would provide better performance, reliability, and scalability than using CSV files. Finally, the use of Power BI gives users flexibility and control over their analytics. Power BI is a powerful BI tool that allows users to visualize and analyze data in a way that's meaningful and insightful. It provides a wide range of reporting and visualization options, as well as advanced analytics features such as machine learning and predictive analytics. Overall, the modular architecture, ability to adapt to different data sources, potential for using a managed data store, and use of Power BI for analytics all contribute to making the Fantasy Hockey project more flexible, scalable, and robust. These design choices allow for easier maintenance, updates, and expansion of the system, as well as providing valuable insights and analysis for users. The MySportsFeeds.com NHL seasonal team stats provide a detailed overview of how each NHL team is performing throughout the season. These statistics cover a wide range of categories, such as games played, goals scored, power play percentage, penalty kill percentage, and many others. The data is updated regularly and can be accessed through an API or web-based interface. Daily fantasy users can leverage these statistics to gain insights into how teams are performing. They can use this information to build more effective lineups and make more informed decisions when drafting players for their fantasy teams. For example, a daily fantasy user may use these stats to identify teams with strong power play units, which could increase the likelihood of a player on that team scoring points. Overall, the MySportsFeeds.com NHL seasonal team stats provide a valuable resource for daily fantasy users looking to gain an edge in their competitions. The MySportsFeeds.com NHL seasonal player stats provide a detailed overview of how each individual player in the NHL is performing throughout the season. These statistics cover a wide range of categories, such as goals, assists, shots on goal, plus-minus rating, and many others. The data is updated regularly and can be accessed through an API or web-based interface. Daily fantasy users can leverage these statistics to gain insights into how individual players are performing and make more informed decisions when drafting players for their fantasy teams. They can use this information to identify players who are on hot streaks, have favorable matchups, or are undervalued in the fantasy market. For example, a daily fantasy user may use these stats to identify a player who is consistently generating a high number of shots on goal, which would increase the likelihood of that player scoring points. Overall, the MySportsFeeds.com NHL seasonal player stats provide a valuable resource for daily fantasy users looking to gain an edge in their competition. This project was designed to automate data ingestion by using 2 Python scripts with a master Python script. These scripts retrieve team and player stats from an external data source and store the data locally for further analysis. The master script automates the process, making it easy to run daily. The system is programmed to run from a local environment, but it can be migrated to a cloud environment if needed. This provides flexibility and scalability as the system can be easily adapted to accommodate changes in the data source, user needs, or other factors. Finally, the system can be scheduled to automatically run daily, ensuring that the data is always up to date and available for analysis. The system uses 2 CSV files that correspond to a Python script. One CSV file contains team stats, while the other contains player stats. These CSV files serve as the primary data feeds into Power BI, which is used to visualize and analyze the data. Microsoft Power BI is a flagship analytics offering from Microsoft that's used to create data visualizations and interactive dashboards. Power BI can be used to create a dashboard that visualizes player and team stats. One of the key advantages of Power BI is its ability to integrate with multiple data sources, including Excel files, CSV files, and REST APIs. This flexibility allows users to easily connect to a wide variety of data sources, ensuring that the dashboard is always up to date with the latest player and team stats. Power BI can be run locally on a desktop or laptop computer, or published to the cloud-based Power BI services, making it easy to share the dashboard with others. The cloud-based offering provides additional benefits such as real-time data refresh and collaboration capabilities. Power BI is a powerful and flexible tool with many out-of-the-box and custom charts that can be used to visualize data in a meaningful and insightful way. The architecture was designed to be low cost for the hobbyist. This means that the tools and services are either free or low cost, making it accessible to a wide audience. For example, the PyCharm Community Edition is a free, open-source integrated development environment, IDE, for Python that can be used to develop and run Python scripts. MySportsFeeds.com is a subscription-based service that provides access to NHL player and team statistics, but the cost is relatively low and can be easily incorporated into the project budget. Similarly, Power BI has a free version that provides access to many of the same features as the paid version, making it an excellent choice for creating data visualizations and analytics. The use of Excel CSV files also provides a low-cost option for storing and analyzing data. By providing a low-cost starting point for hobbyists, the system can be easily built up to create more interesting and complex statistical analyses. For example, users can leverage more advanced statistical models or machine learning algorithms to gain deeper insights into player and team performance. Ultimately, the system can be scaled up to become a professional, data-driven statistics and insights website. By starting with a low-cost, hobbyist-oriented architecture, the system can be easily adapted and expanded as needed to meet the needs of a growing user base.